Hi guys, welcome to our YouTube channel Flow Labs. Today, in this video, we are going to show you how to download Arduino IDE and run some few codes related to blinking of the LED through analog digital means. Video is gonna be really informative for you guys. Stay back and look, enjoy. So as you can know, the first step towards loading Arduino Uno or Arduino Nano, whatever the microcontroller that you're using, is to understand how to code it. So the first thing that I'm going to show you to you right now is downloading Arduino Uno IDE. That is a software that is used to program Arduino based microcontroller. So as you can see on the web page, you have to type Arduino IDE. Once you open the tab, once you have downloaded that thing, there are options you reject. It's up to you. Then you can go to downloads based on the processing system that you have, whether it be Windows, whether it be Linux or Mac. You can just tap on these icons and get it done, download it. So it's a very simple process that you have to do. So yeah, they ask for a donation that if you want to be carefully or just download. Once you are able to download it, as you can see, they ask for your email option for subscription letters if you don't want it. As you can see, this is currently getting downloaded into all this. Once you download it, you have to execute the file, run it to your system, and within no time, things your download would get completed. This is the first step that you want to do towards Arduino IDE, how it functions. Now, I'm going to show you how various things available in it. As you can see, this is a Arduino IDE dashboard that you get once you download it up. So there are multiple options available in this. I'll give you an example how you can run it, how you can do everything in it one by one, step by step. Okay. So just to give an example, this is a sketchboard where you write all the codes, you execute them. Once you write the board, this is a Mac OS that I'm using right now. So you will see all the commands based on the Mac OS system. So once you get it, you will get options such as, so once you have downloaded it, there are certain ways that you have to do to connect the board to the, so the first thing is you're gonna go into the sections and select the board that you're using. So board managers, you have to click on the board manager. You got to select the board that you are planning on using, like AVR boards, Arduino Mad OS. You have to download the board basically that you're using based on this board manager system. Once you're able to go, then you can go for all types of Arduino board like Arduino Uno, Arduino Uno Mini, Arduino Nano. So whichever board you're using, you have to use that exact board, because if you use some other board, it won't function properly. So that's the first thing. Once you have done that, the second thing is port. So basically, there are different ports available. Once you connect the Arduino Uno to your computer, you'll get a board that Arduino Uno port number, COM number 8, COM 6. Based on that, you have to connect it. Once you're able to done it, then you won't find any problem. So that's first two things that you have to do. Second thing is, I'll explain you, this is a sketchbook that all the codes that I have made or written. This is a board manager. Basically, it's a, what board do you want to use? So it's an option. It's a library manager. So everything that we run over here, they run on basic libraries. So they have certain libraries you have to download it from over here. Let's say downloading the content, downloading any other examples. Then this is a debug option. But so if I give you an example, like let's say this is it. You go to options in which you download a code, basically include libraries. May you have options to include libraries of different sketches. And examples, you have an option, let's say for basic like digital button blinking or whatever it is, blink without delay. If you just click on them, you'll find it. This is a basic code that was given in it, how to run blink code. This is a very basic code that you can see once you get it. So once the first thing is, once you make the code, you got to go verify and compile. That's it. Qualified board determine. Yeah, once qualified board is this. So if either selects, you have to select the board from here. Yeah, it's not connected currently, so you won't be able to visualize it, but just one example that I'm giving you. Once you do it, this is where you're going to see everything in detail. Hi guys, as you can see, this is a tab that I've opened. So if you want to simulate the designs online by your own self, you won't have to buy the hardware directly. Program, it's a bit of tedious task, I know. But if you want to do so, you can just go ahead, search for Tinkercad. Once you get the Tinkercad, then you have to log in into this page. Once you're able to log in into this page, you got to sign in with your account. I have already signed in my account. So that would mean once you're able to sign into your account, you can access all the circuits and everything. So just to give a reference, so this is a circuit that I've already made for you guys for LED blinking, potentiometer and the actors. So here what you find is different types of cells, parts available for the battery, capacitor, microvolt, whatever it is, piezoelectric, multimeter. These are basic components. You can go for all Arduino basic components, different types of, if you go, you can directly find different types of programs and projects that are already there. Tone melody that you can do, try it out, digital read serial, analog read digital serial. All these products are pre-built in it. If you not want to do it, you can make a custom, as I have made it a custom way that I have shown you, or you can add parts to it based. This is the LED that you have used, the registers, and this. So the first thing that I want to share with you about is we are going to try to first of all do one thing that we are going to do is we are going to blink the LED digitally using another two commands. So this is a pin that I have connected. So connections are based on this. So first of all, I have connected with red pin to the fifth pin, and third pin I've connected to the right. This is a pin. Two pins available. This is the potential that we have used. So connection that you have to do is you can directly apply 5 volts to LED. It will get short because of increase in current that is provided to it, and it will get short. So we have used a capacitor resistor over here. The resistor value is 150 ohms. You can go and change the capacity of the resistor as well. So you just click on it as 150 ohm based on the capacity 5 volts. If you go for higher, like say 500, 600, 1000, 10,000, 10K or something, then at that point instead of time, the brightness of the LED would get deteriorated consecutively because it requires certain amount of current. If you're not able to give it to that, the power output is very less. And based on the potentiometer, as we all know, the first pin is for 5 volts, second pin is for the analog input, third pin is for data. As you can see, there is PWM available because because of help of PWM, you can vary the brightness of other LEDs. That last video I've talked about it. PWM pins, these are. And this is the analog. As you can go for the code, as you can see, this is a code that I already have. Okay, this is a very basic code that I've made for you guys. So once you're able to get this code, so this is the code in which I'm going to show you two operations. First of all, the pin that I've declared. So once you start making the code, you have to declare all the pins available in it, like constant, integer, digital pin, whatever it is. So as you can see, the first pin that I've declared is A1, as we have combined A1 as analog pin and that we have combined potentiometer. A3, third pin as LED pin, fifth pin as a digital output pin. So this is that we have used. We are using previous mils as the function that we are going to use, and blink interval is 1 second. So after every 1 second, the LED is going to blink. Now, why we have used 10,000 is milliseconds. So millisecond is 10 to the power minus 3. If you use, let's say 100, so it's going to be 0.1 seconds, the frequency of this. Then LED state initially it's set to 0. Now, the main function that we have to use is voice setup. In that voice setup, you have to declare the pin, if it's an input pin or output pin. As you can see, it has declared that LED pin and digital pin output pin. That you have to mention whenever you do void setup. That's a very important thing. Declaring first the pin that you're using. Second thing is void setup, in which you declare the function if it's input and output. A second is a void loop. I mentioned the read potentiometer set brightness on pin 3, integer volt brightness. So basically, we are getting analog read from pot pin. We are plotting it from 0 to 1023. As we have mentioned, the analog input that Arduino Uno can take is from 0 to 1023. That I've done. And make analog write based on the brightness that is mapped out on. That's the first thing. Second is blink and independently. So once we are using blink pin, if current minus is used, so basically blinks a toggle between after every 1 seconds. And say LED state takes the state, save in the previous state, and then keeps on toggling the pin. Now I will do experiment of few of the things and then I'll show it to you. Okay, it works. So as you can see, we have put the code aside. We have put this thing also aside, and we'll start simulation. Okay. So we have initialized the simulation. Yeah, as you can see, this is a digital pin. That the first thing that we have encountered is blinking at a second or 1 second. Now I'll do some changes. As you can see, if I increase it to, some people might have doubt, what if I increase it to 10 kilo ohms? See, if I increase it to 10 kilo ohms, you can see the brightness, the sudden change in the brightness. And it's the same I did it for what? 150 ohms. The brightness of the LED has increased exponentially. So this is something that you can see. And even if you look at it, this is a very interesting thing. This is programmed in such a way, if you don't do it properly, you can get an indication also. See, this indication, see, this what? It mentions what? Current through D5. Current through D5 is too much and it's gonna, let's see, the commit current is 52 while there's 20 milliamps, and that's gonna harm the LED and that's gonna harm the board. So you gotta do proper calculation before deciding the resistor that you're gonna use. For this, it's 150 ohms, so that's perfectly fine, as it can work properly. The second thing is, I was talking about potentiometer. Okay, so let's just start with it. Get started with it. So as you can see, we have taken potentiometer as well to increase and decrease the brightness of the LED. So as you can see, if you look at it, this is a potentiometer. As soon as I increase the resistance, as you can see, decrease it, decrease, the brightness of the green LED keeps on increasing and decreasing. And that's a very good thing. As you can see, you can control the brightness of the LED using a potentiometer from outside. It doesn't pit. And the application of this can be varied. You can control the speed of a motor, control the things of motor, but the only thing you have to mind is you have to use a PWM because that's what it is. Once you're able to do it, you'll be able to do it. So let's say if in the code, if the millisecond that people might have doubt on, okay, if 100 if I do it, what? Let's say if I do it 100. So I have to stop the simulation first, go in, change it to 100, and now start the simulation. And if you can see, the LED will toggle at a very high rate. See, the LED is toggling at a very high rate. That is what Samhita I've talked about, right? Once you stop the simulation, now, so as you can mention, component list is mentioned over here, what all things I have used. Second thing is that I mentioned over here is the schematic of the Arduino Uno LEDs, what pin that I've used. So basically you get quite a good amount of stuff available over here. So now you can make a changes to it accordingly. Now let's go to part. You want to see the DSOs, okay? Multimeter where you can see the waveform, right? You got to go search DSOs, it's a power display oscilloscope. So if you go and search for the oscilloscope, you will see how it functions and what are the ways you can function it, right? So I will, as I selected you as the oscilloscope, you connect one of the point to ground as usual, right? So in that also, one thing you have to remember that all the points that they've used, the ground is used black. So it's a basic phenomena that is used all over this place. When you demonstrate black, you have to use it as a means of black color. So it's become easy for the person who is performing the experiment and who is doing it to understand it properly. Because if you use other color, it's going to be a bit tricky. Yeah. And then I want to give you an example how the output gets changes, right, of a green LED. So if I connect directly this is the output pin, that is the red one that gives the output. So if you look at it, this is it's going to work. Now 100 milliseconds, it's more than enough. Now if I start a simulation, you're going to see what are the waveform that is happening. Okay. So see, as soon as I increase the potentiometer, the waveform becomes very thick, right? And if I decrease it, it becomes, so if I go for, instead of 100, if I go for 10, you will see a very different change in it. See? Hmm. See, the waveform changes suddenly out of everything. Now you can see this is a waveform that I've used. And waveform keeps on changing simultaneously as soon as you decrease and increase the potentiometer value. So it is something that you have to understand how it changes, how it functions, and how it does it. So you can use oscilloscope available there itself, to modify the situations to get it as LED brightness increases, decreases based on the potentiometer value that you're using. Yeah, so this is it. So if you want to learn about it, there are a lot of things that you have to learn about it. So this was just a simple example of how to use oscilloscope to see what are the actual values. So if you go in a real world problem, this is going to be the same way how it's going to function. And just to give an example, this is something that you can get waveform, how the PWM, the thickness of the wave increases as you do it with the potentiometer. This is the code that is available. We will provide with you code in the comment section along with the circuit. As you can see, you can use it by yourself, try it out, and I hope so you'll able to understand Arduino Uno theoretically, right? And in future, you're going to have a lot of projects that we're going to share with you with source code, with simulations, with animations and everything in detail. So sit back, have fun and enjoy. And do subscribe and like to our YouTube channel, Signalful Labs.